I was asked to take a look at and explain problem 6 in the Chapter 8 assignment. So let's take a look at this problem real quick. I've already put in the correct answers so that you can see them, and I'll simply focus on explaining how I got these answers. So we're looking at the annual starting salaries for college graduates with degrees in business administration, and those average salaries are expected to be within $30,000 to $35,000. They want to assume a 95% confidence interval estimate for the population mean annual starting salary. So the idea is we're going to take a sample and come up with this interval estimate. To do that, we need a planning value for the population standard deviation. Now, you have to recall that the formula for the sample size is n equals z sub alpha over 2 squared times sigma squared divided by the margin of error, or E squared. So the planning value for the population standard deviation is what they're asking you to find here. And the issue is they didn't give us anything from history. We're not taking a pilot study. And they didn't provide any best guess. So the last option for selecting a planning value for the population standard deviation is to take the range of possible values. In this case, the range is 5,000, 35,000 minus 30,000. So it's a possible range of $5,000, and divide that range by 4. If you divide $5,000 by 4, that's how you get the 12,250, or 1,250. They next ask you for the size of the sample you need if you have a desired margin of error of 300. They then change it to 250 and then 130. So you can use that planning value and the z sub alpha over 2 for a 95% confidence interval, which is going to our toolkit. That critical z value, z sub alpha over 2, is 1.96, rounded to 2 decimal places. I've put in the 1250 from the first part of the problem, and starting off with 300, we would get a sample size of 67. I've already, as you can see, put in the confidence level that's desired, which is 95%. I've put in the planning value for the population standard deviation, and as you can see in the toolkit, there's actually a little comment reminding you of how you come up with that value. Option 4 is what we use to get the 1250. We put in our desired margin of error to get the sample size calculation. We can then change this to 250 to yield the 97, and change the margin of error to 130 to get the 300. The last part of the problem then is asking, would you recommend trying to obtain a $130 margin of error? And if not, explain why. Well, of the options they give you, you should reason that getting that small of a margin of error, $130, would require you to sample an awful lot of graduates. Now, if you can get to 356 graduates, no problem. But that might be too large a sample to do in a timely manner and at a reasonable cost.